Hello everyone, how are you student? I hope you all are fine today. So today, and you all are busy in your schedule, your busy schedule. That's good, that's wonderful. But today in this video, I am going to teach you and explain you about the mirrors. About the mirrors. Already in the last video, I taught about the natures of light. What is the light? What is the natures of light? And then I taught you about the reflection of light. Then the reflection of light. But in this video, we are going to discuss and explore the knowledge about the mirrors. So we will discuss about the point number 4. From point number 4. Okay. Now the topic is mirror. What is mirror? In physics term, mirror is the any polished surface or a smooth surface that reflect the light. Any object that have a ability to reflect the light, and that object must be polished and smooth. That is known as a mirror. So what is a mirror? If any object have polished and a smooth surface, and it reflects the light, and it reflects the light ray. Reflects the light ray. So notice that this is the mirror definition. If any object have a polished and a smooth surface and it reflects the light ray, that is known as a mirror. Now generally mirror is two types. One is a plane mirror and another is a spherical mirror. In this video it is not written how many types of mirror, but I am telling you the types of mirror. So there are two types of mirror. First one is the plane mirror, and second one is the spherical mirror. Second one is the spherical mirror. Second one is the spherical mirror. Plane mirror, which we are using daily to groom ourselves, to see ourselves, to check ourselves how I am looking handsome or not, I am looking beautiful or not. So that is a plane mirror, but a spherical mirror is different. And this spherical mirror has some types. The spherical mirror also two types. One is the concave mirror, another is convex mirror. A spherical mirror also are two types. A is concave mirror and B is the convex mirror. Yes, so now this is the two types. Two types of a spherical mirror. Mirror. What are they? Concave mirror and convex mirror. Now here we are going to discuss about the types of a spherical mirror. Now here it is written types of a spherical mirror. Two types of a spherical mirror. One is a concave, another is convex. Concave mirror now concave mirror. If you see the concave mirror structure, the concave mirror is bulging outside, inside the clear, but outside is the bulging one. Outside the bulging one. Now this is a cave one, and this mirror is known as a concave mirror. This mirror is known as a concave mirror. And convex mirror is, this is a convex mirror. This is a convex mirror. This is a convex mirror. Now this is the reflecting surface of the mirror, and here this is the reflecting surface of the mirror. Surface of the mirror, and reflecting surface of the mirror. Yes or not, students? So these two types of mirror. Now the mirror formula is 1 upon f. 1 upon f is f stands for the focal length. I will write here. The mirror formula is, what is the mirror formula? The mirror formula is 1 upon f equal to 1 upon v plus 1 upon u. Here u, f stands for what? Where f stands for focal length, stand for focal length, and V stand for the image of an object, and U stand for object. Yes or not, students? V, F stand for focal length, V stand for image of an object, and U stand for object. Okay. So that's why this is the mirror formula. What is the mirror formula we have? We have mirror formula 1 upon F equal to 1 upon V plus 1 upon U. This is our mirror formula. This is our mirror formula. Okay, now magnification. Magnification here. Children, we have some here we have magnification. Magnification M equal to, where magnification formula is, what is the magnification formula? M equal to minus V upon U. Minus V upon U. V stand for what? M equal to what we write? Height of image. Height of image upon height of object. Height of object. Okay. Where V stand for the image and U stand for the object, and HI stand for the height of image. Height of image, where HI stand for the height of image, of an object, and HO stands for the height of an object. Yes or not, children? So this is the magnification formula for the concave mirror. Now here concave mirror as well as a convex mirror. For the mirror there is one formula, 1 upon f equal to 1 upon v plus 1 upon u, as well as a magnification for the mirror m equal to minus v upon u equal to height of object upon height of equal to height of image upon height of object. Okay, now here see, this is the concave mirror and this is the convex mirror. Now in the concave mirror is the converging nature of light. Concave mirror is the converging nature of light, and convex mirror is the diverging nature of light. Now first here the concave mirror. First one is the concave mirror. Now let's draw concave mirror. After that we have to extend a line from the center of the mirror, and this point we must have to consider is P, and after that another point we have to consider C, and another point we have to consider F. Now the distance between P to C is center of curvature. So here C is stand for center of curvature. C is stand for what? Center of curvature. Now here where C stand for radius, center of curvature. Sorry, C stand for center of curvature. Center of curvature. And F stand for focal length. F stand for focus. And P stand for pole. So these 3 points we must have to remember in this. P stand for pole, F stand for focus, and C stand for pole. And while we are mentioning these F points, so this F point must be between the C and P. It is the half of the C. It is the half of the length of C. Half of the length of C is, how we will find the focal length? So we are finding focal length F equal to C upon 2. We are writing C upon 2. Yes or no? If we want to find the radius of curvature, then how will we find? 2 into F. 2 into F. This is the formula to find the focal length and find the radius of curvature. Okay. Now in this concave mirror is diverging nature of converging nature of mirror, converging nature of light ray, and in the concave mirror the real and image will form real as well as a virtual. Real as well as a virtual. Some cases are here. In that case, the virtual image will form. Virtual image will form. But which case the virtual image will form? When an object placed between F and P. F and P, then the object image will form virtually. Object image will form virtually. So in this case, the virtual image will form, but remains case the real image will form. But in the convex mirror, always the virtual image will form, no real image will form in the convex mirror. Okay. Now next we will move forward about the lens. Next we are going to discuss about the lens. Already the mirror is over. In the mirrors in the mirror we one more topic which we have sign convention. Sign convention of the mirror. Sign convention for the mirror. Now for the sign convention for the mirror, for that we must have to draw a concave mirror and convex mirror. Concave mirror and convex mirror. Here in the concave mirror, we are keeping a point here first P. First we are keeping a point here, first point, then second point, then third point. And here we are writing P, here we are writing C, here we are writing F. Now, while we are talking about the sign convention for the concave mirror, then height of object means height of object H O, height of image H I, and V and U, V and U, F, as well as these things we have to remember. So here what we are taking, height of object always we are taking positive in the concave mirror, height of image always we are taking the negative as well as the positive, negative as well as the positive. Okay, in a single case the image, height of the image will formed as a virtual, so that's why upright, so that's why we will take the height of image as a positive here, and image always negative here, negative as well as a positive, and height of the object is here, object distance is negative, object distance is negative, and focal length is negative. So these things we must have to remember. Now next one, magnification. Magnification here M. Now next one for the convex mirror. Convex mirror. This is a convex mirror. We have to mark the point. So this is a P and this is a P and this is a F and this is a C. C, F, P. Here height of image, height of object, height image object image distance, object distance, and then focus, okay, center, radius of curvature is center. Okay, so now here height of image is, what is the height of image? Positive. Height of object negative or positive, positive. Distance of image, distance of image, what is the distance of image here? The distance of image always positive, always positive. Distance of image always positive, and then the next one, distance of object negative, focal length is positive, radius is positive. So these are the sign convention for the mirror. Now next one for the lens. Next one is the lens. Next topic is lens. Now lens. So lens is two types. Already we learned about the mirror. Mirror are two types. A similar lens also two types. Lens. Two types. One is a concave. First one is a, what kinds of lens? First one is concave lens, and second one is a convex lens. 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 Convex lens. First one is a concave lens, and second one is a convex lens. Concave lens, here in the lens, concave lens is what? Diverging in nature of light ray, but here the convex is a converging nature of light ray. Okay. Now, so in the concave lens here, two possible cases are here, and in the concave lens, the image will form upright. Upright means what? Virtual image will form. But in the convex mirror, one case the virtual image will form, and remains case, in the 5 case the real image will form. So here in the convex lens, real as well as the virtual image will form. Real as well as the virtual images will form. Images will form. But here only virtual image will form, because it is a diverging nature of, and this is a converging nature of light ray. The convex lens is a converging nature of light ray, and this is a diverging nature of light ray. Now, if you see here, two types of lens. How many types of lens? Two types of lens. Now, the formula of lens is similar to the mirror, but the sign is different. Here. The mirror formula. What is the mirror formula? You say, children, the mirror formula is what? Yes, you are saying right. 1 upon f equal to 1 upon v plus 1 upon u. But in the lens mirror formula, lens formula is lens formula. Lens formula. Lens formula 1 upon f equal to 1 upon This is the lens formula where F stood for the focal length and V stood for the distance of image and U stood for the distance of an object. Now, magnification of the lens. Magnification magnification of lens. So here m equal to what we are writing? Here we are writing V upon U equal to height of image upon height of object. Here we are not writing minus, here we are writing plus. As you can see here, also it is given, written here also. The magnification of lens is m equal to V upon U equal to height of object upon height of image upon height of object. Now the power of lens is given 1 upon P, 1 upon F. P equal to 1 upon F is given. P upon F is given, and here whatever the focal length is we are measuring in meter. So, and unit of lens is diopter. Unit of lens is diopter, and here convex lens always positive one, and concave lens always negative one. So that's all for today. We will discuss the elements topic in the next class. We will discuss about the sign convention of the lens, sign convention for the lens, as well as a thin lens images we will discuss, and combination lenses we will discuss, and total internal reflection we will discuss, the important formulas and trick for remember and high-level points we will discuss in the next video. So that's all for today. I hope you are getting the concept which I am teaching through this video. So please keep watching, keep subscribing, keep learning, keep sharing my videos. Thank you. We will meet soon into the next video. Bye bye. Have a nice day.